Are you recording right now?
Yeah, just started.
Oh, okay, I'll ask you later.
Okay, okay.
Are you recording?
Here we go. Oops, can't show that. Uh, okay, here we go. All right, class, I wanted to share a few things with you. So I'm going to open up our course. Let's see, we got 21C right here. So as you know by now, we're in chapter 13. Hopefully you can see that we haven't really done any calculus. In fact, we haven't done any calculus yet. We've just been studying so far. Let's see, vectors in 2 dimensions, vectors in 3 dimensions. We've learned how to add and subtract them. We learned how to take a scalar and multiply times a vector. We learned how to find unit vectors. We've learned what coordinate unit vectors are, how to find magnitude. We've also learned how to multiply two vectors together. There's two ways. There's the dot product and the cross product, which was 13.3 and 13.4. And but the idea with this first chapter is to give us these new toys to play with, and vectors are one of the toys. We've got some other toys too. I think you guys have seen, let's see, spheres. That's an example of a surface. And you've probably seen planes. I think you saw planes. We're going to look at some other surfaces. We're also going to look at these things called space curves or planar curves. And we're going to need all of these tools as we progress, as we get into the calculus in later chapters. So one of the things about this course is it is extremely difficult to understand the material without having some kind of visual thing to tie to. So that's why I have this Math 3D link here. So if you click this, it will take you to math3d.org. And I've already sent an announcement about how to create vectors on this, but I want to kind of show you around so you can start experimenting. I don't have enough time to show you everything, but you guys should be able to play with this a little bit. And maybe if you want to go above and beyond, maybe on your discussions later on, you could, link a picture to your posts or something like that. So, anyways, over here, we're in the main category. There's also a little category for axes, axes and camera. Let's go back to main. There's a little button here that says add object. These are the different types of objects that we talk about in multivariable calculus, and they have the basic ones. They have a vector. So I'm going to close out this one. This was just a default one, so I'll just X out. There's the vector 3, 2, 1 right there. You can see you have the X, Y, and Z axis. You can move your kind of point of view by holding down your mouse and dragging. If you hold down the shift key, is it shift? No, it's command. I thought there was another one. Oh, I'm sorry. Depends on your computer. If I put two fingers down on my mouse pad and I can zoom in and zoom out. All right. There are some examples of things you can kind of play with over here if you want to mess around with this. For example, let's see, using variables and sliders. This is a surface. We're going to study surfaces later on, but you can play around with them. Here's vectors and tails. I think I sent you this one already. Here's the stuff you can enter in to graph the things. You can change the colors up here, like so. It'll change the colors down in your graph. There's some settings in here. For vectors, you have a little place you can put in where you want the tail to start at, where you want it to end at. You can put in a label. Play around with some of these, see what you think. Um, um, and you can also do these things with sliders. In any case, so far we've really only worked with vectors, which would be right here. And what else have you worked with? Oh, by the way, that's a 3D vector. If you want to work with vectors in 2D, what you could do is just change that to a 0 and then kind of take your graph and look at it from above like this. And now you kind of have a 2D coordinate system, right? You have the x-axis on the right and the y-axis straight up. And then if you just kind of ignore the third component, you can make vectors, this way in 2D. This program is built for 3D though, so that's why I kind of have to do that. So lines, you can probably guess what this is doing is it's creating a line that joins these 2 points in space. So if I wanted to join the point, let's see, 3, 2, 1 to -1, -1, I can turn the visibility on the first one off just by clicking there. And there's my line in space. Okay. We have done a couple surfaces. We've done, I think, basic planes and we've done spheres. So let me show you how to do that. For this, you're going to use this button that says implicit surface. So, this surface is a surface we're going to talk about pretty soon, but let me type one in for a sphere. So as you might recall, the equation of a sphere centered at the origin with radius 3 would look something like that, right? X squared plus y squared plus z squared equals 9. Now, if you look at the graph here, it doesn't quite look like a sphere. It looks like a squished sphere. So the reason why is just because of our axes. We've kind of compressed our scale here. And if I go down to the z-axis here, I can change that to a 1. And now I get it. I have it more so it looks like a sphere. You can change the color of the surface over here. There's kind of a greener color. So you can play around with that. You can change the range, which you're looking at your graph right now in the x direction. I'm moving -5 to 5, same in the y and same in the z. But there is some other settings in here. If you click the cogwheel, there's an option here for opacity, which is a number between 0 and 1. What this allows you to do is to see through the sphere. It'll make it opaque. So if I put 0.5, it's now partly see-through. And as I near that closer and closer to 1, it becomes less and less see-through. Okay. Now, what is this? The samples. The samples thing is basically telling the program, the online software, it's telling us how often to plot points. So right now it's set relatively low at 20. If I change this number and increase it to, let's say, 40, what you'll notice is the sphere looks more like a sphere. It's definitely got some edges to it, but as I increase this number, it'll just look a little better and better. Now, if you increase it too high, unfortunately, because we're rendering stuff over the internet, it just doesn't have enough processing power. So you'll have to back it up into something that, for which it does have enough processing power. So the opacity would be useful, let's say, if you wanted to plot, let's say, a vector underneath it, and you wanted to be able to see where the vector starts and ends. If the opacity is set to 1, you're just going to see the tip of the vector there. There's also, some shading stuff. If you don't want any shading, there's some other stuff too. I wouldn't really worry about that. What if we wanted to introduce I think we did basic. What did we do? Yeah, we did the basic planes. So I would go over here to implicit surface. And you could type in a plane like x equals, let's say, 3. Oh, what happened? Let's get rid of that. X equals 3. So that's the plane x equals 3. And again, you still have the same settings here. I could change the opacity so I can kind of see through it a little bit. Now I'm going to show you something else. There's a way that you can kind of bring these, make these come alive using a slider. So if you go down here to it says variable slider, you notice the variable here is t. And right now it starts at 0. It's set to 0, but it ranges between -5 and 5. So if I change this to a t, by the way, you can make that variable whatever you want it to be, but let's just use a t. And then you can see what happens to my graph of my plane as I let t change in value. As I let t change in value between -5 and 5. Okay, so you can graph a whole bunch of these at the same time. Let's do a sphere that increases and decreases its radius. Let's do z squared, and then I'll make this r for radius, and I'm going to add in another variable slider. I'll change that to an r. I'll make the minimum 0 because it doesn't make sense to have a radius of less than 0. And then watch what happens as I increase this. Okay, there's my sphere. There's the equation of the sphere, and as r is increasing, the radius is increasing. And if you want it to look nicer, use a 40 there. All right, we can go all the way up to, let's go up to radius 3. That would be an r value of 9. And you can see how we can play around with this and see both of them at the same time. Okay, now you can put sliders and stuff anywhere you want. You might want to take a look in here in the axes and camera controls. For camera controls, there's some options for rotating and zoom. I would just leave them the way they are. This option right here, orthographic projection, basically includes and excludes kind of 3D projection. So let me try and explain that. You'll notice that everything in kind of the front here is bigger, and in the back things are smaller. It gives a 3D perspective. When you turn off when you turn on the orthographic projection, you lose that kind of 3D nature. But it's great for looking at things without the 3D nature. So if you're doing stuff in 2D, it's really helpful because there's no perspective in 2D. Okay, but in general, for 3D stuff, I just leave it off. And then I already mentioned axis and grids, and you can change names and play around with that. And again, if you want to learn some more or play around with some examples, I would click here and look at some of these over here. By the way, let's say you have a graph here, and let's say you wanted to share it. If you go up here to share, and you can take this link and just copy it, and you could put it in your post, let's say a discussion post, or maybe you want to ask me a specific question about something, and it'll post a link to this exact object that you've created, I think along with the code as well. Okay. All right, so Laura, do you have any questions about, I know it's just you, Laura, but do you have any questions about this program or anything you
Uh,
want to
Not
go
at
ahead?
this moment. I think I need to play with it first to see if I
Exactly. Yeah,
have any questions. And I mean,
exactly.
it's interesting, and I like that you're providing something of a visual for me to play with, so I can have a better grasp of understanding of the radius and stuff.
Okay, great, great. Yeah, that's what it's for. And yeah, you're exactly right. You kind of have to play with it, and then when you get stuck, you can ask me or ask someone else. But we'll get through it.
I
Okay, so
appreciate the tool. Thank you.
yeah, this is a great one. I've looked around for the best program for this class, and um, this one was built specifically for this class, multivariable calculus. And I have some other options too, but they require you learn some programming. So I'll put it up there. It's called Mathematica. It should be there. I guess I removed it. But we'll use Mathematica later on. There's some stuff where it's going to be helpful, but for right now we don't need it. And then Desmos, I'll let you play around with that one. Most people are already familiar, but you just go to the graphing calculator and you can type stuff in. And if you click up here where the three lines are, there's some examples of stuff, and it's pretty self-explanatory. And the one thing I would point out though is you might want to mess with the settings here. You can add in grids and change the range on the X and Y axes and labels and steps, and you might want to look into that. But other than that, it's pretty straightforward. You could also share your picture if you have a picture you want to share. You go up here to share, and it's kind of the same idea. You just copy the link, and then you can share it with whoever you want. Okay, and remember the cog wheels are for settings and things, so it's very similar to the last program I just showed you. Okay, but I also wanted to share this online program. This is kind of what would you call it? It's it's kind of like Mathematica. It's a computer algebra system, but it's kind of a stripped down version. It'll do some graphics, and it'll do a lot of the stuff that you just saw with Math 3D, but it requires a lot more input. So I really wouldn't use this one too much for graphics, but it's great for doing computations. For example, I had a student that asked, I think yesterday, what the cosine inverse of like, I think it was like 12 over 37 was or something. So what's cool about this website, wolframalpha.com, is it's a natural language website. So it'll try and understand what you're asking. So if you said something like, what is the cosine inverse of, let's say, negative 12 over 37? Now, what it's going to do is it's going to try and interpret what I'm asking it. Okay, now it might not get it right, or it might get it right. Let's see. So if I press enter, you'll notice in the first line right here where it says input, this is how it's translating what I asked it. Now, this isn't what I wanted. I wanted the 37 underneath the 12, the negative 12. So what I'd have to do is go back and see if I could make it so that it understands what I'm asking. So I want the negative 12 over the 37. So what I could do is maybe, what if I put in parentheses? You can just kind of try stuff. Press enter again. Oh, there it is. This is what I want to find. So the cosine inverse of negative 12 over 37 in radians, in decimals, is 1.9 approximately, and it gives you a bunch of decimal places, but also gives you a conversion in degrees, which is 108.9 degrees. There was a problem in your homework that you might want to use this. Okay, but in general, it even does, you know, pretty much anything you would need to do in calculus, including differentiation and integration and series and all that stuff. So like, for example, um, what's you could just say differentiate uh, cosine of 3x, enter, and there's the derivative right there. Now I want to stress something because for some people they might think, oh, I just gave you a cheat code to all your work. Yeah, I mean, the idea with this stuff is that you only want to use it to kind of check your work. Okay, so you need to know how to do the math because you're going to take a test and you're not going to have this program come test time. So what I would do is as we progress into the calculus, you can use this program to check your work, but don't use it as a substitution for your work. It's great for doing, stuff on the calculator, like adding, subtracting, and getting decimal approximations for things and whatnot. But just be careful it doesn't replace your actual work. All right, it can pretty much do everything that we do in this class. If you want to learn more, let's see, there should be a tour here, and there should be math here. Where's calculus? Calculus and analysis. And then you can kind of see what it can do and what you kind of want to type in. Even if you don't type in the words exactly, it'll try and interpret it, which is a real useful thing. It's kind of nice because in a normal programming language, you have to type it in perfect. Here's sums from Calc 2, vector analysis. We're going to do gradients, so this will do gradients for you. We're going to calculate curl, um, inflection points, a bunch of stuff. So anyways, yeah, I would explore that, especially when you're doing stuff that does require a calculator with, some computations. I think, Laura, you had said you'd use a different calculator to work a problem. You kept getting different answers. This will ensure that the calculator is interpreting the problem as it's supposed to, because the first line will tell you, it'll tell you how it's interpreting what you're asking. That way you know what it's reading, if that makes sense.
Yeah, that's good advice. I'm going to try this one for sure.
Yeah, try it. This is the best one as far as, you know, getting everyone to type. Yeah, because everyone has different calculators, and if I
Yeah.
tried to help you with yours, like it used to be you had to type everything backwards. I don't know if you remember that, but a few years back, you had to like type in the times first and then the three, and
Yeah.
was really weird, but it's gotten better with parentheses, but still every calculator is a little different. Okay, so explore that. I encourage all of you to, because that's going to help. This program will help a lot. And then I think I did want to mention one other thing. Um, oh, my instructor notes. You know, you guys do have a link to the textbook, but you might as well use my notes because my notes are like they're in 3D and they're animated. So like for example, you know, you let's see, let's see, what section are you guys? Are you guys on
4.
13.4? Okay, I'll show you 13.3 just because you just did that. Um, download and open. There it is. So I kind of made these, and I used a lot of material from the textbook. But the idea is to learn this course in a visual way. So, you know, there's a lot of material here, but it is a dense class, and I try and walk you through it in my own words. But for example, right here, here's the zoom. You're learning how to take the dot product of two vectors, u dot v, and you're trying to intuitively understand what it means. The dot product will give you a scalar result, a number, right? So one of the things you want to do is get comfortable with kind of visually trying to understand what a dot product does. So for example, if I've got this vector u in red and this vector v in blue, and I take their dot product, intuitively speaking, what is that resulting number representing? Well, we know what it is mathematically. It's magnitude of u, magnitude of v, cosine theta. But here it is in kind of a visual manner. It's that green arrow right there. And and the way you can kind of get an intuitive understanding is by playing around with these vectors. Like let's say the vectors point in the same direction where theta is 0. Well, if theta is 0, you have cosine of 0, which is 1. And then it's just the magnitude of u times the magnitude of v. So it kind of makes sense that your dot product would be over here on the far right, which is magnitude of u, magnitude of v. This is just a real number line. That's all that is. And you can see as you increase the angle up to, let's say, 90 degrees, well, at 90 degrees, cosine of 90 degrees is 0, and it just kills the dot product. It turns it into a 0. And as you go further this direction to an angle of 180 degrees, it maximizes the dot product on the negative side, and this would be the maximum negative. Cosine theta becomes -1. So you'd want to kind of play around with this and kind of get an intuitive feel for what's happening to the dot product. And then what you could do is say, well, what if we change the lengths of the vector? How does that change? How does that change? So the idea is to kind of play with these. And I've got a bunch throughout the course. Not so much here, but I kind of work through everything in detail. Here's another one where you can see the difference. You can see vector projections where I take a vector u and project it onto a vector v. That's called the vector projection right there. So the idea is to kind of use these to help you explore. You know, in a textbook, things are static like this. And, you know, you can definitely learn from it, but it's definitely nice to have something that moves around. It gives you a better sense of what's going on. Like this one right here, it gives you a little sense for how the vectors change as the angle changes. Okay, so that's that. Let me go back. See if there's anything else. Also, this guy right here is really helpful, this study card. Have you seen this, Laura?
No, I have not.
So this guy right here gives you kind of a quick summary of each of the chapters that we cover or the topic. So vectors in geometry and space. It kind of summarizes the main stuff.
Where is it at?
Oh,
Is it on Canvas?
yeah. Oh, yeah. It's in the resources tab.
Oh,
And if you go down to where it says Calculus 3 study card,
oh, okay.
Yeah, and I would, if you can, download it and print it out because it kind of goes through all the main stuff. You
Oh,
know,
it does. This is great.
yeah, this will help quite a bit. But the thing is, remember, come test time, you're going to be allowed three note cards, 3 by 5 inch note cards front and back. So you're probably going to put a lot of this stuff on there, but probably some other stuff too, that's
Okay.
going to help. But for right now, we're just doing, this is kind of the core of what we're talking about in chapter 13. There's some other stuff too that I haven't, that's not included there. Like, here we go. These guys, planes and surfaces in space. Um, this is, that's not until the next section, but it kind of, it's set up so where it mostly progresses through the material, but this will have all the key parts that you need to know. Okay, so that is a resource available. And it's old stuff. Yeah, and the last thing I would say, I know I keep sending stuff out about this, but I just want to remind you, the discussions are there. I think they're worth like 5%. It's not worth that much. But the whole point of the discussion board is for you to pick a problem for which you would like feedback on. I'm not like grading these problems saying, oh, you got this one wrong. I'm not going to give you any points. That's not how I'm looking at this at all. What I'm looking for is for a student to give me their best shot at, a problem, write out their work, write the problem statement completely as it's stated, exactly as it's stated in my lab, and then write a complete worked out solution like you would write on an exam. Don't skip any steps. If you're wondering whether you should skip something, don't do it. Add extra steps, Try and explain it to someone that's just learning the class. That's probably a good way to judge whether you should be including, anything in there. Um, so again, the idea with this is to kind of help you prepare for your exams. I do grade partly on notation. So, and then also, at this level, you're graded on the presentation, the argument, the notation, the terminology of your worked out solution. I'm not looking for an answer. I'm looking for, a paragraph of information, showing me step by step how you got to each thing. That's we're looking for arguments at this level, and as you progress, you'll be looking at working with in that you're working in that way more often, especially once you get past differential equations, and it's all arguments after that. Okay, and let me see if there's anything else. I think that's about it. I would make sure to read the responses on your discussions. I'm kind of in there, in and out. I can't check everything because I've just got multiple classes, but I'll jump in whenever I can and offer some advice. And yeah, and try and this, but stay up with the due dates because you do have, what is it, 3 sections per week? It's brutal. But it's what we have to do to get through the course. Here's the good news, guys. Your tests are weighted heavily. That's not the good news, but I did build in some time. Where is it? I did build in, let's see, a week and a half for you to prepare for exam one and another week and a half to prepare for exam two.
Excuse me, Professor.
Yeah.
For exam one, will you kind of gently guide us to like what sections you're going to be focusing on?
Oh, it's all of it. Yeah. So what I'll do is I'll give you a list of all the things I want you to be able to do. For example, one of the things on the list might be able to find the angle between two vectors, or be able to find the magnitude of a vector, be able to take a vector and change its length to 10, or change its length to something else. So these are all things that you're doing in your homework, and this will basically ascribe a concept to that, and then you'll go through your homework, and you'll want to kind of organize your thoughts so that you know how to do each of these things. That's the idea. Yeah, so I'll post that probably the next couple weeks. And then what I would do at some point is, you could kind of start studying early. You can cross off the ones that you're sure you know how to do. Um, You might want to reach out to me for notation stuff. It is part of your grade, so I will mark you off somewhat if you, forget to write a vector variable as with the arrow. Um, there's a bunch of notational things you'll want to kind of stay on top of.
Will you be requiring a pre-approval of the cards before the exams?
Oh, yes, yeah. And for the cards, you can write anything you like on them except for worked out examples. So you can't write your homework problems on there and work it out. You could write, formulas. You could write a paragraph explaining how to do, a certain type of problem, like general steps. You could write definitions. Um, and I will check that like right before as you come in, I'll read through them and give you a little mark, make sure it's all good. If not, I'll take it away, but hopefully that won't be an issue. Okay.
Okay,
So
thank you.
yeah, so it's a lot, I mean, you guys have 3 sections a week, so um yeah, do your best. Make sure to reach out to me. I've got office hours Tuesday, Wednesday, Thursday, and based upon my survey that I sent out, I'm gonna hold Friday optional office hours. You'll have to make an appointment with me, but I'll make sure I'm available. I think it was 5 to 7 p.m. on Fridays. So I'll send an announcement about that shortly. But if you want to meet with me, you need to make an appointment. Um, but I'll make sure to be available if anyone wants to meet. Okay, I think that's it for this meeting. So let me